Good afternoon, everybody. Welcome to an afternoon of Chem 170 with your host, me, Dr. White. Actually, sort of sad because it's our last meeting together. Next week, I'll be giving the final exam for Chem 170 online. So we won't have any meeting. And the Wednesday afterward, I got a doctor's appointment, so I won't be able to do that. And anyways, I've given the final. What more is there? Now, important thing I do want to say up front, because of a change in Zoom, uh, I have to, and I'll send out an email later today, set up new office hour with a new login set up. And I'll send that out in an email for today's office hour tonight and next week, Monday and Wednesday. And I'll send that out later today before the office hour, obviously. All right, let's do the following. Let me remind you, next Monday by 1 p.m., probably because of some other things I have to do on Monday, I'll send it a lot earlier. You'll get a email with the password for the Chem 170 final exam PDF file. You'll have until the next day, the 13th at 1 p.m., which means you got 24 hours to take the final exam and upload your answers. It's important as a single PDF file. I reserve the right to subtract up to 50 points for anyone who doesn't follow instructions, meaning uploading it as a single PDF file or doesn't do it on time, upload on time. All right, take as much time as you need, either you know it or you don't. Most students, when I do this similar type finals, not the exact, but similar, when it's face-to-face before the pandemic, took about 75 minutes to 90 minutes. I gave them 2 hours. I'm giving you as much time. This is not an open notes or open internet test, and I will know if you've gone there. And I will do what's in my syllabus if you cheat. So please do not cheat. All right, final exam, as I mentioned earlier, has 32 problems, 18 pages. Here's the breakdown in terms of general knowledge, like how many bonds to carbon, and nomenclature, which is here's the structure, give the IUPAC name, here's the name, draw the structure. And reactions, give the organic product or products. A couple of them will be give the starting materials. And based on the material of each of the 4 tests, test 1 has 35 points, test 2, 60, test 3, 58, test 4, 53, new material, which is amino acids and proteins, 4 points. It adds up to 210, and that means 10. Let me bring my picture back up over here. 10 bonus points. All right. Now, if you have any questions, email me on Monday or Tuesday. I will have my office hour for a while on Monday night, if you have any questions. With the grading, I hope to have everything done by, if you're taking on Monday, hopefully by Friday, if not earlier. Let's make it Saturday, 1 p.m. I guarantee it, which means I'll be a lot earlier. I will post your grades on D2L. When I do, I'll send out an email. I'll also post it in the official ECC system. I think it's ECC My Portal or something like that. And usually that takes about 24 to 48 hours before you see it officially. But whatever I have in D2L will be the official grade, because I'm going to use the same. I'll send out an email to you when that's all available. Let's see, I did the Zoom meeting lecture change, the final. One personal note, if you like what I did this semester, go to ratemyprofessor.com, let everybody know. If you didn't like what I did this semester, go to ratemyprofessor.com and let everybody know. And if you really, really did like what I did this semester, and I'll send it out in an email, send an email to Dr. Sam, president of ECC, and copy the board of trustees and let them know how well I did. And if I really did a really, really bad job, do the same thing. Send an email to Dr. Sam, president of ECC, and copy the board of trustees. They should know either way. All right. What I'm going to do today is, first of all, I'm going to finish the review for test 2. I'll do test 3. Normally in the past, I haven't done test 4, but because I just went through it last week, but I'll do it again today because some of you were not here when I cut it out of the video for the answers for test 4. And then we'll do our trip to a chemical plant. All right, let's get going. Test 2 review. I think I ended, if you take a alkyl halide with magnesium, you'll get a Grignard. And then with a ketone or aldehyde, when R prime is H, you have a Grignard first step where X is chlorine, bromine, or iodine, and second step acid and water, and you do that special thing, you form a carbon-carbon single bond. Now, I don't know why, but a lot of students have trouble with this reaction on test 2 and the final. Hint. All right, remember, double bond between carbon and oxygen, a carbonyl, is a pi bond. Add hydrogen to catalyst, you break the pi bond, and each atom gets a hydrogen, you make an alcohol. Now, because this will attack if you ever had double bonds in R prime or R double prime, carbon-carbon double bonds, someone came up with lithium aluminum hydride. And that someone was, oh, I can't think of his name right now. I forgot. Oh, mental block. Dr. H.C. Brown, I think it was H.C. Brown of Purdue. And lithium aluminum hydride will only react with carbonyl compounds, not double bonds. So if you do that first, second step acid and water, you do the same thing. You break the pi bond between the oxygen, and each atom of the double bond gets a hydrogen. And finally, I talked about the aldol condensation, which a lot of students have trouble with too. So study it. Alpha carbon attached to the carbonyl is acidic. You react it with sodium hydroxide, a base, and water. You form the enolate anion, take off one hydrogen, it's a minus charge. That attacks the other carbonyl of the other aldehyde, like a Grignard, and opens it up to an alcohol. And this is one of those special reactions where you make a carbon-carbon single bond. And this is also one of those students have trouble with. So study. Let's move on to test number 3. I'm going at a quick rate because you've already learned this stuff. And if you want, you can go back and watch the video and slow it down. So I sound like this. Anyways, all right, let's take a look at the following test 3 review. Carboxylic acid, R group on a carbonyl with a hydroxyl group. Nomenclature. Find the longest chain with a carbonyl carbon, name it as an alkane, drop the E, add the letters OIC in the word acid. And remember, the carbonyl carbon is always 1, but we don't put that there. And you name the rest of the alkyl groups like you've done in the past. Now, I asked you to learn a couple of common and common/IUPAC names. And the first one is acetic acid. Nobody calls that ethanoic acid, except say nobody calls it ethanoic acid. And that's the carboxylic acid found in vinegar and ketchup, mustard, and relish, and pickles. They all have vinegar. All right, formic acid, which is the carboxylic acid that the fire ants use in their weapons to protect themselves. They spray it on other animals with hot water in it, mixing hot water from their body. That's when R is an H, and that's it. Now, when R in a carboxylic acid is a benzene ring, the old name, common name, IUPAC also made the IUPAC name, and that's called benzoic acid. Now, carboxylic acids are acidic, donate a proton. The acidic proton is the hydrogen on the oxygen of the carboxylic acid. And if you react it with a base where M is lithium, sodium, or potassium, you'll get the carboxylate anion. And remember, what I'm going through, test number 3 review, is cleverly hidden in the lecture section of D2L, named test number 3 review. Sneaky. Now, one thing I did want you to know was the special reaction of a carboxylic acid with baking powder. I guess I forgot to write all baking powder on there. And there, if I ask for all the products, you get the carboxylate anion. This forms carbonic acid, which breaks down to water and CO2 as a gas. And if you remember, I told you the little story about the rocket ship. Oh, it's a fun memory. And also my father's way of making better spaghetti sauce by putting a little baking powder in there that deals with the citric acid from the tomatoes, and you'll see some foam, the gas on top. Now, how do you make a carboxylic acid? Oxidize a primary alcohol. Also, you can oxidize an aldehyde. And finally, one that I like because it involves a Grignard reagent. Take Grignard reagent, react with carbon dioxide, usually dry ice will do the trick, and second step acid and water, and you get a carboxylic acid that's 1 carbon longer than the Grignard, our group you started with. All right, next I talked about esters. And esters are carbonyl, R group, oxygen on the R group, on the carbonyl, and another R prime on the oxygen attached to the carbonyl. Now, for an ester, name, IUPAC name R prime as the alkyl group it is, and put that in front of the name. Then there's 2 different ways of dealing with the carbonyl carbon and R. IUPAC is name the carboxylic acid used to make that ester, drop the OIC in the word acid, and add, or IC in acid and add ATE. Now, when R is not a benzene ring, you can use what a student of mine came up with, and I don't take credit for other people's work. Name the alkane from the longest chain with the carbonyl carbon, drop the E and add OATE. Common name, this ester, nobody calls ethyl ethanoate, except when to tell you don't call it that. Everybody calls it ethyl acetate. And just to remind you, ethyl acetate is one of the 2 molecules used for nail polish remover. Oh, I forgot to put my nail polish on today. Dr. White does it. My grandfather and brother-in-law used to have it years ago. If you went in the barber shop, the better ones, they all had manicurists, that men would have a clear coat put on their nails after the manicurist clipped them and made them look nice. All right. Again, ethyl acetate is one of the 2 nail polish removers. Now, this is a carboxylate anion, which you saw you make from base and a carboxylic acid, where for my class, M can be lithium, sodium, potassium. It can be a lot of other things too, but I've limited it for this class. Now, how do you name these? Name M plus as the element it came from. Like if it's Li plus, that would be lithium, or sodium, or potassium. Then, just like esters, you either do 2A or B2. If I say 2B, I'm going to have to say 2B or not to be. That's the question. That's why I call it B2. All right. Now, you should know esters are responsible for the smell of most flowers and the taste and smell of many fruits and vegetables. Would I ask that? I did on test 3. Time out for a public service announcement from your host, me, Dr. White. To study for the final, use your tests 1, 2, 3, and 4 for practice problems. If you notice, my own practice problems were similar, not the same always, as what was on the hourly exams. And guess what? The type of problems you've seen all semester are what I will have on my final exam. Therefore, you should use your test 1, test 2, test 3, and test 4 as practice problems for you to work on. Now, you don't have the answers unless you came to class. If you need any help, always feel free to email me. I check my email twice on Saturday and Sunday, and every other day too. Now, my twice is very early in the morning and later in the afternoon or early evening. All right, back to our regular scheduled review. How do you make an ester? Fischer esterification, take a carboxylic acid, react it with an alcohol, acid catalyst, and you make an ester. The carbon with the hydroxyl group in the alcohol will be the carbon the oxygen the ester is bonded to in R prime. Again, the carbon in R prime with the hydroxyl group of the alcohol will be the carbon in R prime of the ester that this oxygen here is bonded to. Now, once you have an ester, if you react it with acid and water, like what happens in your stomach with fats and oils, you now know, and that is you get back the carboxylic acid and the alcohol you would have used to make that ester. If you take an ester and react it with a base and water, it's called saponification of an ester, where M can be lithium, sodium, or potassium, you get back not the carboxylic acid, because in the presence of base, the carboxylic acid forms the carboxylate anion, but you also get the alcohol you would have used to make that ester. Now, heads up, the following reaction, which Dr. White really loves, should I say it a third time? Really loves, is an ester with 2 molecules of a Grignard and acid and water. And you make not 1, but 2 carbon-carbon single bonds, and the OR prime is kicked out as a second alcohol. If you keep R prime very small, like a methyl or ethyl, you can remove that alcohol to get the bigger alcohol here you wanted. Now, listen carefully. Students have trouble with this on test 3 and also the final exam. So study this, so you won't have problems. All right, next I talked about amines. Those are derivatives of ammonia, where you remove the hydrogens from NH3 and replace them with alkyl groups, primary amine, secondary amine, tertiary amine. I'll never ask you what's a primary amine, secondary, tertiary amine. How do you name them? The common name, I didn't ask you to learn the IUPAC name, which I did teach you how to do, but I didn't ask you to learn it, is name each R group on the nitrogen as the alkyl group and put that in front, and then add the word amine at end. Now, there's a special amine you should know the structure of. When R is a benzene ring, the common name, which became the IUPAC name, is aniline. Now, something near and dear to my heart because it helped me get around the world, paid my salary for many, many years, helped me get new cars and other things, was quaternary ammonium salts. That's where you have a nitrogen with 4 R groups. Because of that, it has a positive charge. All molecules in nature have a net 0 charge. So you have an anion to make sure it's a net 0 charge. And it can be many things, but for this class, I kept it to the halides. X is chlorine, bromine, or iodine. Now, how do you name it? I taught you the common name, not the IUPAC. Name each R group as the alkyl group it is, and you put that in the front. Then add the words ammonium halide. Now, if it's bromine, Br minus, it's ammonium bromide. If it's Cl minus, it's ammonium chloride. If it's I minus, it's ammonium iodide. Now, let me remind you, quaternary ammonium salts, and I have patents in this area, a number of them, are used as a key use is fabric softeners and antimicrobial compounds such as in mouthwash. Now, guess what? I messed up on here. Sorry about that. Well, you make mistakes in life. There's one of mine. All right, now, this is an amine salt. R prime and R double prime can both be hydrogen or one or more alkyl. And how do you name them? Identical to the quaternary ammonium salts. You name all the R groups, put that in front, then the word ammonium halide. And depending what X is, X minus, it's ammonium bromide, chloride, or iodide. Now, how do you make amines? If you take a primary alkyl halide reacted with ammonia in the presence of base, you get a primary amine. Again, X can be chlorine, bromine, or iodine. If you take a primary amine and react with an alkyl halide, the presence of base, you make a secondary amine. And if you take a secondary amine and react with an alkyl halide, the presence of base, again, these are all called nucleophilic attack, the carbon with the halogen or the nitrogen non-bonding electrons attacks the R, in this case, double prime carbon with the halogen and bonds to that, kicks off the 8X halogen to H, and the base neutralizes HX. And you get a tertiary amine. Now, if you take a nitrile carbon-nitrogen triple bond, reacted with excess hydrogen and catalyst, nickel, platinum, or palladium, you break the 2 pi bonds, each atom of the triple bond gets 2 hydrogens. This is an outstanding way of making a primary amine. Now, something very near and dear to my heart, and that is if you take a tertiary amine, react with an alkyl halide in the presence of base, you'll make a quaternary ammonium salt. And go back and look at the test number 3, and you'll see I have the reaction that helped make me a lot of money. A lot. Now, amines are bases. And if you react it with an acid, you'll make the amine salt. Excuse me. And remember here, the way I had a general reaction, R prime and R double prime can be hydrogen or cannot be. One or more can or cannot be. So this covers a primary amine, secondary amine, or tertiary amine. And they all form amine salts. Now, next I talked about amides. Amides are carbonyl with an R group The carbonyl is bonded to nitrogen, and our nitrogen, you have R prime and R double prime. And please note, R prime and R double prime, one, both, or none, can be hydrogen. And remember, I told you about the dumbest thing I ever did was to taste some habanero powder, and the heat and peppers is due to amides. And I used like in the mayonnaise, swish it in my mouth and spit it out to get the amide that was burning my mouth from the habanero powder out of it. Thank God I remembered I thought how to do that. Now, how do you make an amide? If you take a carboxylic acid and react it with either ammonia, primary amine, or secondary amine, you'll form an amide. In this case, this nitrogen, R prime and R double prime, one, both, or none can be hydrogen. If they're all hydrogen, that's NH3. If it's not, it's a primary or secondary amine. And you form your amide. Now, once you form an amide, what can you do with it? Well, in your stomach, if you're eating protein, which is held together by amides, acid and water, you get back the carboxylic acid you would have used to make that amide and the amine salt of the amine. Because in the presence of acid, amines, which are bases, form the amine salt. Now, in this amide, as all amides, R prime and R double prime, one, both, or none can be hydrogen. Now, if you take an amide and react it with base and water, excuse me, with base and water, remember R prime can be hydrogen, one, both, or none. You get back not the carboxylic acid you would have used to make that amide, but the carboxylate anion of the carboxylic acid you would have used to make that amide. Why? Because in the presence of base, the carboxylic acid makes the carboxylate anion. But you do get back the amine you would have used to make that amide. Now, I talked about heterocyclic compounds, and you should know a heterocyclic compound is a ring with carbon and other atoms such as oxygen and nitrogen. And I only asked you to learn one heterocyclic compound, that's pyridine. It looks like benzene, except one of the carbons in the ring has been replaced by nitrogen. Boy, that was going quick, but don't forget, you've already covered this. You've already learned this stuff for test 3. I'm just doing a quick review that you can go back and watch the video or look at the actual printed review. All right, let's go on to test number 4 material. Remember, the final covers all semester. And first of all, I started talking about a polymer. And you should know a polymer is a macromolecule. That means a big molecule made up of, why is talking all the time is bad for my throat. Let's see if it works now. Test, ketone, aldehyde, it's working. All right, polymer, macromolecule made up of repeating units called monomers. There's two ways of classifying polymers, one by chemical property, one by a key physical property. And by chemical property, you should know there's 2 types. Addition polymer, that's a polymer with only one type of a monomer, and you should know examples like I asked in test number 4. Rubber tires and saran wrap are examples of addition polymers. Condensation polymers are made up of 2 or more different types of monomers. I really should have here different. And examples of that, my water bottle, the plastic here is an addition polymer. And if you had anything made of nylon, like a nylon jacket. Now, when it comes to physical property, we talk about thermoplastic polymer, which is a polymer once it's formed, it can, the plastic tells you that, can be reheated and reshaped. An example, that was my water bottle and saran wrap. There's no relationship between thermoplastic, the physical property, and if it's an addition or condensation polymer. You just got to find out in the lab. And a thermoset polymer is once formed, it cannot be reheated or reshaped. An example of that are rubber tires or urethane foam, like in the cushions you're sitting on a chair or in your car. Now, next I talked about fats and oils, an area I worked in heavily in the chemical industry. And I taught you what is a lipid. That's a molecule from plants and living things that are soluble in nonpolar solvents, but not in water. And when we talk about lipids, there's two types. Saponifiable lipids, otherwise known as fats and oils, that yield carboxylate anions of fatty acids, plus other things, glycerin, in the reaction of base and water. A non-saponifiable lipid does not react with base and water, and those are your steroids, otherwise known as your hormones. Now, I asked you to learn that a fat is a solid or semi-solid triglyceride at room temperature. An oil is a liquid triglyceride at room temperature. And here's the structure of the triglyceride. 3 esters in the same molecule. Now, I asked you to learn, and I taught you that if you add acid and water to a fat or oil, you have an ester, acid and water, you get back the alcohol plus the carboxylic acid you would have used to make that ester. And in a fat or oil, you have 3 esters, so you get 3 alcohols in the same molecule, glycerin, plus in this example, these 3 carboxylic acids. If we treat a fat or oil with base and water, called saponification of an ester, as you learn for test 3, you get back the alcohol plus the carboxylate anion of the carboxylic acid you would have used to make that ester, 3 esters, 3 alcohols, and 3, when this example, because our prime and our double prime, 3 different carboxylate anions. Next, I taught you that 2 ways to catalyze the reaction. One is by acid or base catalyst, using a catalyst, or I shouldn't say catalyze, to make a reaction go quicker, use a catalyst like acid or base, or run it at a higher reaction temperature. And to do that, you can use steam. Steam is this very, very dangerously hot water. High pressure steam will kill you. Don't use it, be careful. But in the chemical plants, we are careful. This is where you see this mainly. And if you take an ester, react it with steam, which is hot water, it's the same as acid hydrolysis of an ester. You get back the alcohol and the carboxylic acid you would have used to make that ester. So I have this triglyceride fat or oil, my 3 alcohols, I'll get glycerin, and each one of these esters gives me each one of these carboxylic acids. Now, I talked about fatty acids. Those are the carboxylic acids obtained from fats and oils. And I asked you to learn the structure of stearic acid, which is a saturated fatty acid. It has no carbon-carbon double bonds, only carbon-carbon single bonds, and it's got 18 carbons, and here's the structure. Next, I asked you to learn the structure of oleic acid. Oleic acid is a monounsaturated fatty acid, meaning it has 1 double bond, has 18 carbons, but at carbon number 9, is the double bond that can be cis or trans. Now, I asked you to learn saturated fat has only carbon-carbon single bonds. Unsaturated fat has at least one carbon-carbon double bond. Remember, Mother Nature never did triple bonds, or never has. Now, since I worked in this area, I asked you to learn tallow is beef fat, yellow grease is pig's fat, and white grease is another type of different purity of pig's fat. And as I mentioned, as I mentioned during the semester, I worked in this area, and the company I worked at here in Chicago, where I was lab manager at their plant and research here on this 47th and Racine, a long time ago, we used to purchase about 2 to 3 million pounds a week of tallow, yellow grease, white grease. Now, to give you a real world feel, I came up with a general structure for tallow, yellow grease, white grease, and that's this. And R sub S is a sterile group. That's this part, not counting the carbonyl, of stearic acid. R sub O is an oleal group. That's this part of the oleic acid, not counting the carbonyl. And I asked you, if you took tallow and reacted it with, say, a base and water, what I'm really saying is take this structure, react it with base and water. You have a ester, base and water. You get back the alcohol plus the carboxylate anion you would have used to make that ester. And here we have ester number 1 gives this alcohol plus sodium stearate. Ester 2 gives this alcohol plus sodium oleate. The way I have this picture, ester 3 gives this alcohol, you get glycerin, and you get sodium stearate again. So since we don't balance equations in this class, you don't have to put a 2 in front or write it a second time unless you want to. And these are the 3 different products you get here. And as I went through in class and was on test number 4, you should know how to react this structure with acid and water. We just did here base and water, and with steam. And it's the reactions I just showed you, other than here's now, instead of R prime and R double prime, R sub S, O, etc. Now, leaving my class, you should know, how does soap work? You should know the structure of soap: nonpolar tail, polar head. And dirt and grease are polar, nonpolar. I don't have here. And water is polar. And the key is like dissolves like. And if you didn't write that down in test 4, like dissolves like, I took off 2 points. And you should know that dirt and soap interact to form this called the micelle, because the nonpolar tail is attracted to the dirt, and the polar head wants to stay as far away from the dirt because the like dissolves like. But the whole micelle, which is totally surrounded on the outside by the polar heads of soap, looks polar to water, and water looks at the micelle and says, I'm polar, you're polar, we know like dissolve like, let's go down the drain together. And they do. Now, when it comes to steroids, the only thing I asked you to learn was the ring skeleton. And this is a skeleton of all steroids, meaning all your hormones. And it's 4 rings, a 6, 6, 6, 5. And as you saw in test 4, I asked you to draw it, so you should know how to draw it. All right, next we went on to carbohydrates. And what's the definition of a carbohydrate? A polyhydroxyl aldehyde, polyhydroxyl ketone, or molecule upon such hydrolysis becomes a polyhydroxyaldehyde or polyhydroxyketone. And then we took a detour, chapter 5, if you were reading a book about chirality. I asked you that you should know chirality means handedness. I asked that on test 4. And what is a chiral object? That's a object with a superimposable mirror image, like a needle or a sewing needle. I don't think I'm subject you to any more of my artwork this semester. I don't know if you could handle it. I don't know if I could handle it. But anyways, and a chiral object is something that has a non-superimposable mirror image, like your hands, right and left. And if you can designate something right and left, you don't even have to think about, is the mirror image superimposable or non-superimposable? And on test number 4, I asked you, are the following objects chiral or achiral? Also on test number 4, I asked you, identify the chiral carbons in a molecule. And a chiral carbon is a carbon with 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. And if a carbon has 2 or more hydrogens, it can't be chiral because it's going to have 4 different groups or combination. If it's in a double bond or triple bond, it can't be chiral, like in either carbon-carbon or carbon-oxygen or even carbon-nitrogen. Now, next I talked to you about enantiomers. And enantiomers are the non-superimposable mirror image of a chiral molecule or molecule. And on test number 4, I asked you, draw the enantiomers of the following molecules, which meant draw the mirror images, and you did. Now, a couple of reactions I asked you to learn dealing with sugars. First of all, glucose is in equilibrium with its hemiacetal form. Why? Because a ketone or aldehyde plus alcohol and acid will give the hemiacetal hemiketal. When the alcohol is in termolecular in the same molecule, you don't need the acid catalyst and you have this equilibrium. And you should know this. Same thing for fructose. Here, you have a ketone or aldehyde, or in this case, a ketone, sorry. And just like before, ketone or aldehyde, alcohol, acid, you form the hemiacetal hemiketal. In this case, this alcohol attacks the carbonyl carbon to form this hemiacetal, which I showed you. Now, I think since I've been going at warp drive, let's take about a 5-minute break, come back in 5 minutes. So I gotta stop talking. I've been going at warp drive real fast, but we've already gone through this. Take a 5-minute break. I'll see you at 1:50. We'll finish this up and you'll get your plant tour too. Ooh. See you in 5. let's get going. All right, let me remind you, sometime before 4:30, I'll be sending out an email with the new login for my office hour. Next week, we're not going to have any Zoom meetings, so I don't have to send you a new Zoom meeting because we're going to have the final. And after the final, you're not going to be coming to class. There's nothing more I can do. Well, there's always things I can help you with, but not that. All right, let's get back to work. Now, I showed you that the hemiacetal, the hydroxyl group here, you can react with a different alcohol and acid and replace it with OR triple prime. And this is important with glucose hemiacetal, because if our triple prime is another glucose molecule, that's how you form starches. Now, important things. You should know sucrose is fructose and glucose bond together. And remember, this sucrose is table sugar. The stuff you put in your coffee, tea, or on your cereal, or wherever you're cooking. Now, starch is a polyglucose. It's a polymer of glucose. If I take a lot of glucose molecules and react them together with an acid catalyst called an enzyme, I'll make starch. As you see here, I have that reaction, and I have it here. Oh, wait. Now, if you, in your stomach, there's acid, H plus, really HCl and water, and sucrose is broken down to fructose and glucose. And in your stomach, starch, which is a polymer of glucose by acetal linkage, if you add acid and water, it breaks it back down to glucose, which is why glucose, which is the sugar in your blood, is the most abundant sugar in nature, because Mother Nature gave us and animals a way of eating starch and breaking it down to glucose for energy or whatever. All right, leaving my class, besides knowing how does soap work, and leaving my class, knowing how soap works, you should also know, and let me be subtle for the last time this semester, you should know that when you eat something with a fat or oil, you should know how to describe it with words and a general reaction. And what's the key functional group in a fat and oil? An ester. And that's acid hydrolysis of an ester. You have an ester, acid and water, get back to carboxylic acid, and the alcohol you would have used to make that ester. And you should know how to describe with words and a general reaction, what happens when you eat a fat or oil. You should know how to describe with words and a general reaction what happens when you eat a carbohydrate. What's the key functional group that holds glucose molecules together in a carbohydrate? That's an acetal functional group. And that's acid hydrolysis of an acetal. And the general reaction here, you learned for test 2 was acetal or ketal, acid and water. You get back the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. Now, one last area. and that's amino acids and proteins. There'll be 4 points on the final exam on this area. First of all, you should know an amino acid has the following structure. Oops. Whoops. And the alpha carbon, the carbon bonded to the carbonyl carbon, has the amino group, NH2 group on it. And when R is not hydrogen, this alpha carbon is chiral. When R is not hydrogen, that's chiral. And if you take an amino acid and react it with another amino acid, it could be the same or different. What's really happening? Carboxylic acid and amine forming an amide. And therefore, this will form this molecule. And if you link a lot of amino acids together, 50 or more, you form a protein. And what's the key functional group in a protein? An amide. That's what holds the different amino acids together. Therefore, the following is true. First of all, and usually I haven't talked to, can use a catalyst, not what we use for hydrogenation. And your body, the enzymes, help speed this up to make a protein. And what's the functional group in a protein, the key one? The amide. Now, protein acid, like HCl and water, in your stomach, and you'll get back your amino acids. And you should know, oh, I lied. One more time, I'll be subtle. How to describe with words in a general reaction. Hint, know this, when you eat a protein. And what's the functional group in a protein? An amide. So when you eat it and chew it and swallow it, it goes in your stomach. There's acid and water, so it's acid hydrolysis of, and what's the key functional group? An amide. So how do you describe with the words what happens when you eat a protein, something with protein in it? It's acid hydrolysis of an amide. And what's the general reaction? You learned this for test 3. Take hydrochloric acid, which is in your stomach, water, which is in your stomach, and what you get back, acid hydrolysis of an amide, you get back the carboxylic acid you would have used to make that amide plus the amine salt of the amine you would have used to make that amide. I'm having a bad hydrogen drying day. Oh no. And that's what you get. And with that, couple things. First of all, I'm going to be doing a thing of taking you on a plant tour now, but I'll be cutting that out of the video. How do you like my special effects? My scissors, click, 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 click. And then I'll have a word or two more after we do the plant tour. And with that, I'm going to have to say, the first day of this class, I said, my world of organic chemistry is your world of organic chemistry. You don't know about it. Now I can say, my world of organic chemistry is your world of organic chemistry, and you do know about it. And you now have knowledge that most people on this planet do not have. And something my father also always used to tell me, remember, which is they pushed me to get all the education I could, and I got my PhD, which they were very proud of. I was lucky enough to have them still alive when I received that. And my father used to always say, an education is something, and knowledge is something nobody can steal from you. Nobody can take that away from you. And he was right. And with that, I'll say, for the last time, because there's no Zoom meeting next week. Remember, I'll be sending out later today the new office hour login information. But I'll say for the last time, Gang gesund, which is Yiddish meaning go in hell. Don't forget, get your booster shot if you haven't. I've got my third one about a month ago. And 2 weeks before that, about 6-8 weeks ago, I got my flu shot, and that's starting to get serious in the United States. And with that, I'll say gang gesund. Goodbye.